binomial by name is bi is standing the Greek word for two, and nomial is coming from polynomial. So binomial is a polynomial with two terms. So it can be sum or difference of two terms. So as you can see on the screen, I have tried to give in the example of binomial terms. Like the first one is x plus 1, which is simplest of that. Other is 3x plus 2. So again, you can see there are two terms involved. So it's a binomial. 3x plus 2y, it's a binomial. And a minus b is a binomial. Now, all these three terms, when classified, are binomial expressions. Now, there are certain processes that can be done on this binomial, and they are related to Pascal triangle and binomial theorem. You already know from your previous semester when you are multiplying a binomial with a binomial term. Okay, so we'll start from that point onwards. And if you want to recall what I'm talking about, have a look at start few slides of factorization. Okay, so let's start. So what I have done is that I have started off with a very easy example, which is the first example, x plus 1. Now, like I said, x plus 1 is a binomial. Okay, so what I have done in the next step is that I am squaring this binomial expression, x plus 1. So the next thing that you see, x plus 1 whole square. So this is a binomial term when it is squared. Now, all of you know that when you have x plus 1 whole square, the answer of this binomial term, which is squared, is, if I ask you, then what would you do? You would do simple multiplication. That is, x plus 1 whole square mean that it is x plus 1 multiplied by x plus 1. And what does that mean? That you need to open the bracket and you need to multiply the terms within the brackets. And how you did that? Just to make you recall from the previous semester, first term of the first bracket to the first term of the second bracket, then first term of the first bracket to the second term of the second bracket. And similarly, second term of the first bracket multiplied by the first term of the second bracket, and the second term of the first bracket multiplied by the second term. And this is what you get. And I have tried to color code the answer so that you can see that when you are multiplying x with x, you are getting x square. When you are multiplying x by 1, you are getting x. When you are multiplying this 1 times x, it's x. And when you are multiplying 1 by 1, your answer is 1. Once you have done the multiplication, all you are required is to simplify. That is, make the like terms together. Since x square is the only term, so I have written this x square by itself. X plus x is 2x, so I have written this 2x. And the third term is just a constant because 1 multiplied by 1 is a constant. And if you can see, I have rearranged it slightly differently now. So earlier, I was rearranging it as x square plus 2x plus 1. But now I have rearranged it as 1 plus 2x plus x squared. So I am rearranging it with respect to the constant number. And I'll come to this in the later slides. Now what I do is that I have increased my binomial term exponent. So initially I started off with x plus 1 to the power square, and then I did the next step, x plus 1 to the power cube. And now you can see that I have got 3 bracketed term involved. And what I did was that I took the answer of the first 2 bracketed term and multiplied the x plus 1 with this term. When I do that, my answer is now, as you can see, that when the power has risen to exponent n equals to 3, the answer, the binomial expression that I am getting is in terms of cubic power. I hope it is clear. Okay, so the next, I'm just trying to make you see that as you multiply the brackets, when the power is increasing, it is getting difficult to keep multiplying the bracket terms. So for example, in x to the power 4, now you have got 4 brackets to multiply. The easiest way was that I took the answer for the first 3 bracket term, which is coming from here, okay, and I multiplied x plus 1 with this. But do you think that if I keep on increasing my power and I keep multiplying by this, would it be easy or would it get difficult?
It would get difficult.
Yes. So if I have got x plus 1 to the power 6, it will get even more cumbersome. So what the result is suggesting is that it will get difficult to keep multiplying as we increase the exponent, and it will become cumbersome also because we have to keep multiplying that x plus 1 by itself again and again. I hope this is clear. So let's come to the second example. Okay, the second example is slightly changed from the first one. Now what I have done is that I would like you to pay attention to the exponent. Earlier, I was trying to emphasize on the multiplication of the 2 bracketed terms or 3 or 4 or 5 bracketed terms. Okay. In example 2, my focus is exponent. So what I have done is that I have taken a binomial a plus b. Okay. A is a constant, let's say, or b is, let's say, x. So is a plus b a binomial? And this binomial, I start off with a plus b whole square to the power 0. Okay, when the exponent is 0, the base gets to 1. So a plus b to the power n is equals to 1. Now I have increased the exponent a plus b to the power 1, which means that it is a plus b. Okay, next, a plus b whole square. You know from your previous information that a plus b whole square is a square plus 2ab plus b square. Okay. Next, a plus b whole to the power cube. Again, you can open it and multiply it, or you can, if you know the answer, you can directly write it as a cube plus 3a square b plus 3ab square plus b cube. A plus b to the power 4. Again, either you multiply a plus b, a plus b, a plus b, a plus b, or if you know the formula, then you can directly write out this. Okay, so there are 2 ways. Either you use the formula, if you remember that, or you start multiplying the term bracket. But here also, as you will see, that the calculation gets longer and longer as we go. But if you look at the answers of all these bracketed terms, there is a certain pattern that is being developed. For example, here you can see a to the power 1, here a to the power 2, here a to the power 3, here to the a to the power 4. So definitely a plus b whole to the power 5 will have a to the power 5. Okay. Similarly, if you look at the second term, start from the a plus b to the power 1. So here the power of b is 1. When a plus b whole square, the power has increased to b square. A plus b whole cube, the power of b is increased to b cube. And in case of a plus b whole to the power 4, the power of b is b to the power 4. Similarly, if I had a plus b whole to the power 5, the last term, which is b, would be b to the power 5. Now, if you look at these terms closely, I have picked up the blue term, which is a plus b whole cube. Okay, so next, if you look at this a plus b whole cube, an answer which is in blue color coded. Over here, I have written the same thing. So if you look at it, the answer, the first term is a cube plus 3a square b plus 3ab square plus b cube. Okay, so your answer, it's the same answer that is written above, but here you can see one thing, that is, in the first case, 3a square b, I have written as it is. With the second term, 3a to the power 1. So this a to the power 1 was not written in above. But now I have written this 3a to the power 1. And there is a reason to that I'll show you in the next couple of slides. Okay? So 3a to the power 1 plus b square plus a to the power 0. So again, if you see this, I have grayed this a because it is not there in the formula. And the reason it is not there shown is because a to the power 0 is 1. So if you look, this is same as the answer that is given in blue color code at the top. However, the thing is that here a to the power, I have written a to the power 0 for a reason, because I want you to concentrate on the exponent of a, which is starting from the highest exponent 3, then it is going to 2, then it is going to 1, and for the last term, which doesn't have this a written, is actually a to the power 0. And that's why you see I've written they start at 3 and go down to 3, 2, 1, 0. Similarly, if you now focus on the same expression but now look at b, which is over here. So now if you look at the b term, so when a is cube, b to the power 0. And because b to the power 0 is 1, that's why it is just written as a cube plus 3a square b to the power 1. When it is written as b, you know that it has got a power 1 plus 3ab square plus b cube. I hope this is clear. Any questions on this?
Shazia,
Yep.
on the fourth term there, that 6 looks out of place. Should they all not be 4? They're just following the pattern or trying to follow the pattern?
This one?
Yeah. Is that right?
No. It should be there.
There should be a 4.
No, it should be 6.
All right. Okay.
Let's see. Let us check. Yeah. Now you have made me slightly mixed up. Okay. So we'll check this. Okay. We'll come to this expression when we do the triangle. Okay. Okay. So now just want to focus on the exponent. That if you now look at this expression, you will see that the power of a is decreasing. As you keep on increasing the exponent, power of a is decreasing over here. Like if you go along to the second term, third term, and so on, and power of b keeps on increasing. So a to the power 4, a cube, a square, a to the power 0. Whereas if you look at b, it is b to the power 0, b to the power 1, b square, b cube, and b4. I hope this increasing of power of second term and decreasing of power of first term is clear. Because next I have used the same example. So now what I have done is that I have said that we have got the number. I have taken that k or n as k is the exponent equals to 0, k is equals to 1, k equals to 2, and k equals to 3. And it is going to so on to n to the power whatever value. Okay. So the first equation is representing this whole line is representing the first term. And this next line below it is representing the second term of the binomial. So if you look at it, the first term of the binomial that I have just explained, a plus b whole cube. The first term is a cube. So I have written it over here. You can check it from here. The second term is a square. The third term is a. And then the last term is 1. Okay. Next, you have got 1, b, b square, b cube. So if you look at it, we can bring up together each one of them as a formula a to the power n minus k or b to the power k. Now let's try this formula. Okay, so let's try this formula. So what if I say that my n is 3? So if my n is 3, I'm using the same formula and I'm putting a to the power 3 minus 0. So this is my formula. On the top, I have written the formula. On the top, as you can see, I have written the formula. So if my n is 3, then it's a to the power 3 minus 0, b to the power 0. When my what n is 3, k is 1, then a to the power square, b to the power 1. When my n is 3, k is 2, a to the power 1, b square. When n is 3, k is 3, this should be 3. Then it should be a to the power 0, b to the power 3 because it's 3. And because it's a to the power 0, you will not write this, but it should be just b cube. Let me, I will change this error, and this is again highlighting the fact that I have to type so much things in the equation editor, and that's the reason I often end up in, making these errors of powers and thing while putting up the presentation. So just remember that it is 3 minus 3 and b to the power 3, and the answer should be b cube. So this is what I have just explained to you in the earlier slide. But now, in order to bring it in terms of a formula, I have rearranged it in this way that what I have just explained was that the first term of the binomial, which is to the power n, would be decreasing its power when it is expanded. Okay, so a cube, a square, a to the power 0, which is 1. Then taking up the second term, which is b. So initially b will be 1, then it will be b, then it will be b square, and then it will be b cube. So now I hope you understand the top table that I have just explained, that here it is decreasing in power. First term decreasing in power, and the second term of binomial expression, it is increasing in power. And with this, I have come up with this formula, and this is a very useful formula. I will come back again on the later few slides. So now you can see that this formula works like a magic, provided I remember this formula and know how to apply. So far, what we have done is that I have emphasized that when you are expanding a binomial term to the power n, how do you arrange the two terms? I hope you are clear now that how the terms have been arranged. So now, even you don't have to even remember for, let's say, a plus b to the power 5. You don't have to remember. All you need to do is to start with the decreasing power of the first term and increasing power of the second term. But so far, what I have done is that I have just tell you how to arrange the terms. I haven't talked about the coefficients. Coefficients are those terms that are there with the, like, constant terms that are attached with the terms. For example, a plus b whole square, a square, plus b square plus ab, but ab has got 2 involved in it. So hence, for same way, I have explained you the term a cube plus a square b plus ab square plus b cube. But both these inside terms involve constant, and from your previous knowledge, you know that this is 3a square b over here, and this is 3ab square, which is written over here. So now that I have developed a sort of a formula, I need to find a way to find out the coefficients of those binomial terms when they are expanded to the power n. For that matter, let's look all the results. So this I started off in the previous slide with a plus b to the power 0, and then I went on to a plus b to the power q. So let's arrange the answer of both for this middle terms and for this. So when I rearrange my answer, I started off with this a plus b whole to the power 0. My answer was 1. A plus b to the power 1 was a plus b. Next, when I had a plus b whole square, my answer is a square plus 2ab plus b square. And when I have a plus b whole cube, my answer is a cube plus 3a square b plus 3ab square plus b cube. I hope you are following this. If there is any question, please ask now. Any questions? Any questions?
Charles, you know the sort of the number you've been given, so a plus b, and you've got it in brackets to the third power.
Yep.
Does that purely mean to the third term, or can you be given an expression to a power, and then you have to take that to a term? Does that make sense?
No, I'm talking about the term within the bracket whole to the power. A binomial term whole to the power.
Okay.
Huh? Let me go back to the previous slide. So here, now I'm putting the answer, all the answer from a plus b to the power 0 to a plus b to the power cube. So I'm just rearranging my formulas. And this is the reason I wrote over here that you should remember that a plus b to the power 0, how you got this one. Okay? A plus b whole to the power 1 is a plus b. A plus b whole to the power square is a square plus 2ab plus b square. And when you increase the exponent n equals to 3, then a plus b whole cube, the answer is this. All I have done is that I have taken the answer of all the 1, 2, 3, 4, and I have rearranged it over here. So this is the answer if I've got a plus b whole to the power 0. And this is the last one is the answer of a plus b whole to the power cube. And in the middle, I did say that, can you see there is a pattern developing? So this was the pattern that was developing. That it started off with 1, and as you increase on the power, on the binomial term, this is how it will increase. Okay? Now what I have done is that in the next, which is the next figure parallel to this, you will see what I have done. So now in the next, this triangle, parallel, this triangle, now look at the terms that I have highlighted. What I have done is that I have highlighted the coefficient, the number attached to those terms. Okay? So in the first case, 1, a plus b whole to the power 0 is 1. So it started off 1, and Pascal triangle always start with 1. Okay? Next, a plus b. So a had a coefficient 1 multiplied to it, and b had a coefficient 1 multiplied to it. Okay? The next term, which is a square, also has 1 multiplied to it. Middle term is 2, so it is 2ab. So I've highlighted 2 over here. The last term, b square, is again 1b square. Next, take the last line, which is the cubic one. So here the first term has got 1, a cube. So here it is 1. The next term is 3a square b. So see over here, 3a square b plus 3ab square. So again 3ab square plus 1. So in the second triangle, I am highlighting the coefficients that are attached to that expression. So when you open the bracketed term, the binomial bracketed term, this is how the expansion will keep on happening. And what you can see over here, that is what I have written, that each number is the middle one. Each number is just the two numbers above it added together. So let's start over here. So it is always the case that the Pascal triangle always starts from 1. All the edges, both sides, left hand side always remains 1, and on the right hand side they always remains the 1. Okay, in the middle what you do is that for the second case, like 1 plus 1 is 2. Okay, now for the third case, 1 plus 2 is 3, 2 plus 1 is 3. I hope this is clear. Any questions on this, or should I explain again? How I got these coefficient, is it clear? Okay, I'm assuming it is clear. Let me, before I go, this is a Pascal triangle. Pascal triangle help us to expand binomial terms that are raised to the power n. So when n is 0, your binomial term answer is 1. When your n is 1, your Pascal triangle will show this coefficient as coefficients. Then when your n is 3, Pascal triangle will show you the coefficient for that. Then when n is 3, then you will see the coefficient as 1, 3, 3, 1. And how you are getting these middle values? You are just adding up the top two numbers together to get the middle one. So for the case of this line, I am adding 1 plus 1 to get 2. For this value, I am adding 1 plus 2 to get 3. And for this value, I am adding this 2 plus 1 and I am still getting 3. The pattern, if I continue it for, let's say, 4, 5, 6, it will be a triangular pattern of number, and this is called Pascal triangle, and it helps us to find out binomial term expansion. So let's try something new. Let's make for exponent of 4, because I just showed you how to do a plus b whole to the power cube. So let's take the another one, which is a plus b to the power 4. So you see the answer that I showed you earlier was this. I will expand this triangle for the coefficient. So now I'm just looking at the coefficient for the moment. I'm not going to look at the terms. I'm going to, because I'm trying to find out the coefficients attached to the terms. So this is how the coefficients are: 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Okay. So if I have to solve a plus b whole to the power 4, what should be the value of coefficients? That's what I need to determine. So let's start with the first one. So let's start with the first case that I had 1 at the top. Then the next two is 1, 1. The third row is 1 box, unknown box, plus 1. But now you know that this box needs to be 1 plus 1. So this will become 2. So this is here, 1 plus 1 become 2. Next, I take another row. And next, when I take another row, my start should be 1 and my end should be 1. So the middle values are unknown. What I need to do, I need to take the top one, the top two ones. So 1 plus 2 is 3. And then I take this 2 with this 1 and it will also be 3. So this is how I got 1, 3, 3, 1. Now based on that, give me the answer. Sorry, this should be 1. So this is my triangle. This is my triangle. Let me, should I correct it now or would you be able to do it? This needs to be 1, okay? So all these triangle needs to be 1 at the right hand edge, as well as all needs to be 1 on the right hand edge. Okay, so this needs to be 1, okay? So all the edges on the right hand side needs to be 1, all the edges needs to be on the right hand side needs to be 1. So you know that the middle term you need to add. So for this term, 1 plus 3 needs to be 4, shown over here. 3 plus 3 needs to be 6. And for the last, this term, it needs to be 3 plus 1, which needs to be 4. I hope you have followed the way I have tried to put in terms of boxes. I hope this is clear. Any questions on this? Any questions on this? So if I have to expand my binomial term a plus b whole to the power 4, I need to have first row, second row, third row, fourth row, fifth row. Okay, so this is the line. This is the line, the last one. Here, the first term will have a to the power whatever, a to the power 4, but the coefficient will be 1. The next term will be 4. What? Can anybody tell me? What should be the next term? 4a cube b. Anybody want to give a try? Nobody is replying.
Sorry, could you repeat that, please?
I want you to put the coefficient in the expanded term. So for example, in this case, this is a cube, 3a square b, 3ab square plus 1b cube. So now for the a plus b whole to the power 4, the first term is a to the power 4. The next term is 4a.
To the power 3.
Yes, good. 4a to the power 3 and b should be there, isn't it?
Yeah.
And then the next term should be 6a to the power, then 4a to the power 0 or a to the power 1. And b, build a triangle. So building the triangle itself is very easy. The thing is that you start from 1, then you write 1, 1 next to it, and please note that this 1 is equally shared by these two ones. Okay. Similarly, these 3 boxes are sharing the top 2 boxes. Similarly, these 3 boxes are equally shared by the 4 boxes below. Then fifth line is equally sharing these 4th boxes. Okay. And this is just to explain you. I could have written just like that. And that's what I'm going to do ultimately after after a few slides. Yeah. But in order to make you understand the pattern, I have drawn these boxes, so you should be able to add them and build the triangle. Now coming back, I just asked you that when you expand this a plus b to the power 4, this is how it is happening, that a will go from 4, 3, 2, 1, 0. B will go to 4, b will go to b to the power 0, b to the power 1, b to the power square, b to the power cube, and b to the power 4. This is how you will come up with the expression terms. And the coefficient all you need to do is to build the triangle and substitute the value of the triangle. So here it is 1 coming over here, 4 coming over here, 6 coming over here, 4 coming over here, and 1 coming over in the last place. I hope now it is clear. So somebody just asked me on the previous slide, they wanted to know that why 6 is here between the two 4 terms. I hope this is clear now. Was it Edmund or Scott?
Yeah, it was me. Thank you. That's clear now.
Yeah. So this is the way that you know how the terms are. You rearrange the terms. Remember, you rearrange the terms. The first term will be in the decreasing order. The second term will be in the increasing order. You can do it, and just to make, because I am experienced, I can do them directly. But as you can see, I have explained in the step that a exponent goes from 4 to 0. So here you can see the first line, a exponent going from 4 to 0. B exponent is going from 0 to 4. And then I have built in parallel the Pascal triangle, and from there I have placed the coefficient values against those terms. Is it clear? Now, in order to help you out, I have also, okay, in the next slide I have done that. So the conclusion for the Pascal triangle is that you start with 1 at the top and then you continue placing number below it in a triangular pattern. The edges, the left hand side edge is 1, always 1, and the right hand side of this triangle edge is always 1. And what you have to do in the middle is that you add the number directly above it and place that number in the box. This is what I just explained to you, that for example, if I take the 4th row, which is this one, I will just add the top 2 boxes and my answer would be this. So it's 1 plus 3, so the answer is 4. This 3 plus 3, answer is 6, and this 3 plus 1, the answer is 4. So I'm getting my coefficient for the middle terms. He added 1 plus 1, 2, 1 plus 2, 3, 2 plus 1, 3, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4. Then 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. So my 5th line of the Pascal triangle is 1, 5, 10, 10, 5, 1. Okay, so with the help of this Pascal triangle, I have determined my coefficients, and I already know that when I am expanding my first term, my power will decrease. The first term power will decrease from n to 0, and for the second term, the power will increase from 0 to n. So based on that, I can do the expansion for a binomial term. Now, if I take the first 8 terms, so you can see I've added few more terms in it. So here you can see that if I add 1 plus 5, it's 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6. And I can keep on increasing the boxes below and keep on increasing, and this will be more easier to build and write the answer than multiplying those brackets. So you have just found out a way that if you want to if you have a binomial term and it has got an exponent n, then you can use Pascal triangle to solve that binomial term. This slide is just explaining you the step individually. So those of you, and majority of you, because you haven't put up any questions to me in my explanation, I have written this step by step how to build a Pascal triangle, explaining how the next term is Next row is coming. So now let's generate the 7th, 8th, 9th and 11th row of the Pascal triangle. So one of your colleagues just did it for 5th term. I won't take a lot of time now because I will go to a higher problem also. So I am revealing the answer that if you do keep on generating the triangle, so for the 7th term, here it is 1, 7, 21, 35, 35, 21, 7, 1. Then the 8th term 1, 8, 28, 56, 70, 56, and so on. You can see that you will keep on increasing the triangle. The pattern over here obvious is, look, at the left hand side it is 1, 1, 1. On the right hand side it is 1, 1, 1. Next you see over here, look at the diagonal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the next 1, 3, 6, so they are quadruple numbers. So the pattern you need to understand the pattern, that when you are trying to expand a binomial term with the power n, you can use the expansion of Pascal triangle. So the 7th term is this, 8th term is this, 9th term and the 10th term. So you can look at the triangle and then you can write out those rows of the Pascal triangle. Next, come to example 4. I'm again taking the simple example because I know that you all know the answer of this expansion. A plus b whole square. So like I said, when I need to expand a plus b whole square, I know that the first term power will decrease and the second term power will increase. But I also know that the middle term will involve coefficient. So I need to build in a Pascal triangle for a plus b whole square, which is just this. So the top one remains as it is. A to the power 1, the coefficients are 1, 1. A plus b whole to the power square is 1. 1 plus 1, 2. So the middle term is 2 and the last term is 1. So the coefficients are 1, 2 and 1. Apart from this information, I already just explained that the power will the first term power will decrease from 2 to 0 and the second term power will increase from 0 to 2. With the help of this information, now I can make up the expansion for this term, a plus b whole square. So now it should be a square b to the power 0 plus coefficient, which is 2, first term to the power 1, second term to the power 1 plus first term to the power 0 and second term to the power square. And as you can see that the first term the power is 2, 1, 0, and for second term the power is 0, 1 and 2. I hope this is clear. Or the other way is that you multiply the terms again, just like I have explained. So your answer, I started off with the same answer. So now if you look at this, a plus b whole square is equals to a square plus 2ab plus b square is actually coming from here. Is it okay? Let's build the a plus b whole cube, which I did in previous example. So here again you see that I have built the Pascal triangle 1, 1, 1, 1, 1 plus 1 is 2, and again this 1 comes at the edge. So here again the third row, the edge is 1, then this 1 plus 1, 1 plus 2 will make this 3, and this 2 plus 1 will make it 3, and the last term is again 1. So the coefficients are 1, 3, 3, 1, and my answer for this would be 1, first term cube, second term to the power 0 plus coefficient 3 times first term square, second term to the power 1 plus 3 first term to the power 1 and second term to the power square plus third term which is to the power cube. This is what it is. So here you can see 3, 2, 1 and 0, whereas the power of b is 3, 0 to 3. So here it is 0 to the power 1 to the power square to the power 3. And if I want to solve it in a traditional way, I can go for the same multiplication. So in terms of Pascal triangle, it gives you more easy way to determine the expansion rather than avoiding that multiplications of the bracketed term. Similarly, I could go on for my a plus b to the power 4. I can build in my triangle by increasing the row. And if I want to increase the power a plus b to the power 5, this is the expansion. So here you can see a to the power 0 is 1, a plus b to the power 1 is this, a plus b whole to the power cube is this, a plus b whole to the power 5 is this, which was initially like I started off with the question and I showed you how it was getting difficult to keep multiplying the bracketed terms with each other. And with the help of Pascal triangle, I found an easier way of not to deal with those bracketed terms and use Pascal triangle to find out the expression when you expand a binomial expression. I hope this is clear.